perform risk calculations. The work required in the Run Rows tab is that the default new study folder is set up with most of the Run Rows sections relevant to this tutorial already defined. However, you will need to define different model selections for day and night since the propane deliveries by tank wagon do not take place at night. In the Weathers tab, we will need to define windrows probability data for each set of weather data. Default new study folder is supplied with some dummy windrows data which you will use for this tutorial, but you should always check the data before starting the calculations. And in the Risk tab, for this tutorial you will set up some simple population data for day and night to define the ignition source. As the day and night Run Rows setup data is already present, we will now view the weather data. Move to the Webs tab section and double click on the folder for the set of day weathers. The Windrows dialog will open. The dialog gives a table of weathers and wind direction with a probability of each combination. You can scan the table to see the predominant weather condition and the prevailing wind direction. In the example study folder, the Windrows data are dummy data with the same probability set for each weather. You do not need to make any changes for this tutorial, so you can click on Cancel to close the dialog. We'll now set up the population data. For this tutorial, the information for residential population is assumed to be taken from census data, and the census numbers are assumed to describe the situation at night time when all of the people are at home. You will set up the night population first as the base population and then later copy and modify it for day. Firstly, we need to set up the night population data. For this tutorial you will only define population around the village to the east and south of the site. You will define the population nearest to the facility in some detail, identifying individual houses or groups of houses, but represent the main village further from the site with a single shape. To insert a point, go to Insert Population Point and place it on the map. To insert a rotating rectangle, click once to place a corner, click again to place the orientation, and again in the opposite corner. To set the size. To insert a polygon, move around the shape in a consistent fashion, clicking to insert each corner in the same direction. And double click at the end to close it. Population data we have set up is firstly a population point called West House, located here, a population rectangle called Long Street here, population polygon for the village, population rectangle for the 4 nearest houses, population rectangle for Short Street, and a population point for East House. If you want the name of the shapes to be displayed on the map, select the population set and then go View Labels. When the icons for the shapes are added to the study tree, you will see the icons for the 2-point shapes have red borders, while the icons for the rectangle and polygon shapes do not. The program has a default value for population density set into the risk preferences under the options menu, and it is used to calculate a default population for shapes that have an area. For point shapes, however, there is no default population, and the icon for these shapes have a red border because they are created with the population value unset. To set the population, if you wish, you can open the input dialog for each shape in turn, but it's easier to open the dialog for the population set, since this allows you to work in all the shapes at the same time. When the dialog first opens, the rectangle and polygon shapes will have the default values based on the area and default density, but the population for the point shapes will be unset. Do not use the default values and instead enter these values. For the west house, population of 4. For the east house, also a population of 4. For the long street, population of 60. For the village, population of 400. For the 4 nearest, a population of 10. And for the short street, a population of 24. The population set dialog only shows the population data for each shape, not the geometry. If you want to set an exact location for a shape, you must open the input dialog for the shape itself, which contains a geometry tab. Click on OK to close the population set data. We now need to define the day population. For the night population, it was assumed that everyone was at home, with 95% of people indoors. For the day population, you will assume that half the people are at home, with 80% indoors, that 40 are at the local school, with 70% indoors, and that the remainder are at work outside the area. To define the day population, copy and paste the night set, and rename the copy day population. Before you can add the shape for the school, you must select the day population set from the day run row. So go to the run rows tab, open up the dialog, and make sure that day population is selected for the day run row, and OK the dialog. Now move back to the risk tab. To add a shape for the school, make sure that day run row is selected, and then select the day population folder and add a shape for the school. The school is a large building on the southwest outskirts in the village, and you should draw it as a rotated rectangle. Rename it school. To set up the population values, open the dialog for the day population set and set the population of the school to 40. Halve the values for the residential shapes and set the fraction indoors to 80. So for the west house, population of 2, long street 30, 200 in the village, 5 in the 4 nearest, 12 on the short street, and 2 on the east house. Set the indoor fraction to 0.8. And OK the dialog. We'll now set up the ignition data. The new blank study folder is created with a single set of ignition data called day ignition. The pattern of ignition sources might be different for day and night, but for this tutorial we will define a single set of ignitions. For this tutorial we will define a single on-site ignition source, a flare located just inside the northwest corner of the site and to the north of the propane sphere. Insert flare as an ignition point. Just inside the site. We now need to set the values for the ignition point. Set an operating probability of 1 and leave all other values as default values, and OK the dialog. We now need to run the risk calculations, so move to the Run Rows tab. Select the Run Rows icon and then select Run Models option for each of the run rows in turn. For each run row in turn, the program will run the consequence calculations for any combination of models, weathers and parameters that have not yet been run, and will then proceed to the risk calculations. The calculation will probably take 10 to 15 minutes depending on the speed of your machine. Once the model has run, we will now view the risk contour plot. Select the run rows icon and then view the risk contour plot. The risk over a year is dominated by the chlorine release, but you can see the contribution made by the propene release to the on-site risk. The default display is of the outdoor risk. If you change to viewing the indoor risk, select Indoor from the risk cascade of the right-click menu. You will see that the risk from the chlorine release is lower. We will now view the FN curve. Select the Run Rows icon and then view the FN curve. The risk is high, with some outcomes causing more than 200 fatalities. If you move to the FN curve tab section, it will show the contribution for the two run rows separately. You will see that the risk is greater for night than it is due to stable night-time weather conditions and their long dispersion distances. We will now view the societal risk ranking results. Select the Run Rows icon and select Societal Risk Ranking Report from the View menu. The report confirms that the risk is dominated by the rupture of the chlorine sphere, with some minor contribution from toxic pipework failure. You've now completed this part of the tutorial that deals with the tasks involved in performing the most common types of analysis, one for calculating the individual risk. You should save the study folder in order to save the changes you have made. By default, the program will only save the input data, which means that the next time you open the study folder, you will have to rerun the calculations in order to view the full results. However, if you select the Save with Results from the File menu, the program will save the full set of consequence and risk results, and you will be able to view the results immediately the next time you open the study folder, although you should be aware that this file may be very large.
This tutorial has not covered every feature of the program, but you should now have enough of an understanding of the approach and methods used in the program to be able to explore the remaining features yourself, with the assistance of the online help. If you need further detail on any aspect of the program, or if you need guidance on how to model a particular situation for your facility, you should contact product support using the details given under product support in the help menu.